Okay, largest positive integer that exists with its negative. You're given an integer array that does not contain any zeros, and you're trying to find the largest positive integer such that its negative also exists in the array. And we return that integer, the positive one, and if one doesn't exist, so basically if there are no pairs of integers, we return -1. So let's look at the first example. Here, we see that the array contains -3 and +3, so each one of these, like -3, contains its negative, because the negative of -3 is +3. And more simply, the negative of 3 is -3. And so the answer is 3, because 3 is the positive integer from that pair. If, let's say we removed this 3 from the array, we wouldn't have any pairs, so we would return -1. So yeah, pretty simple to understand here. In terms of constraints, a couple things to note. One is the length of the array is 1000. That means that if we solve the problem in squared time, that would be on the order of about 1,000,000 operations, which is easily handleable by LeetCode. But we can do this a lot faster. We can do this in big O of n time, which we will do, because you could just brute force this by choosing every pair of numbers and checking if they're each other's negative. But again, that's slow and inefficient. Okay, so how would we go about solving this in O of n time? The first observation is, let's say we're going through each element in this list. It sure would be helpful if we could look up if we've already seen the number's negative, right? So like if we're at 2, it would be cool if we could just say, is there a -2 in the array? If there is, then we know we found the pair, and we can update our answer and see, and say we found this pair of 2 is 2 bigger than our answer. If so, we can update it. So how could we do that? Well, there's a handy little data structure called a hash set, or a hash map. In Python, it's just a set or a dictionary. In this case, all we care about is knowing that the number exists in the array. We don't need any information about it, like its index or how many times it occurs or anything like that, so we can just use a set, because, again, all we need to know is that it exists. So if we have a set, and that will let us, in constant time, look up if a number exists in the array, how would we do this? Well, we can just go through each element. So for -1, have we seen a +1? If we haven't, then we know this isn't part of a pair, at least not yet. So we can add the -1 to the set and move on to 2. Is -2 in the array? No. Or, yeah, is -2 in the set? Have we seen it yet? No. So let's just add 2 to the set and continue. -3, so there is a 3 in the array, but we haven't seen it yet. It hasn't been added to the set yet, so same thing here. We're just going to add -3 to the set. Now 3, is there a -3 in the set? Yes, we've already seen a -3, so we found a pair, and we can update our answer. So that's basically the approach we're going to be taking. I would recommend, if you are trying to actually learn this and struggle with it, I would recommend going off on your own, pausing the video, deleting me, doing whatever you like, and trying to implement this yourself. And if you can figure that out, cool. You understand it, and it will stick in your brain far longer than if you just watch me code the solution and say, yup, I understand. Totally, definitely. But that's my recommendation. Obviously, I am not the dictator of many things, so do as you wish. I will now begin programming it. So let's jump into the code now. First things first, with problems like this, we have to keep track of an answer, because we're trying to find the maximum possible value, so we have to keep track of our current answer at any moment in time. So we'll initialize an answer variable. And what should the initial value for this be? Like, let's say our initial value was positive. Of course, that's bad, because that could possibly not be the answer. So there are a few ways to do this. the general approach that I'd recommend is just setting it to the smallest possible value. So in Python, you can do float of negative infinity. Other languages, you might be able to do like int min, something like that. And this is going to be general. If you're trying to keep track of a maximum value, use the smallest possible value. If you're tracking a minimum, use infinity, the largest possible value. Note for this problem, you know that it doesn't contain any zeros, which means that the answer cannot be 0, so it has to be positive. So if we initialized answer to 0, and at the end we see the answer is still 0, that means we weren't able to find any answers, and we could return -1 in that case. So here 0 also works. I prefer using negative infinity. Do whatever you want, I don't care. Next, as I mentioned, we need a set to keep track of the numbers that we've already seen, so we can just call this seen. And in Python, we just have a set created like this. Next, as I described, we're looping through each number. So for in nums, n is going to be the number that we're currently looking at. First thing we want to check if basically we've already seen it's negative in the array. So if negative n is in seen, basically all we're saying is if we've already seen the negative of this value. And if this is the case, then we know that we've got a pair and we can update the answer. So this is going to be the max of, this looks, what in tarnation is happening? Apologies. Okay, yeah, there were some wacky things going on, I'm sorry. So it's easiest when you're updating an answer for like a max value or something. You just use the max function and maximize it with itself and your new value. In this case, know that we don't actually know if n is positive or negative right now. Because, like, let's say we're looking at this first example, except the numbers are swapped. So this is positive 3, this is negative 3. We encountered positive 3 first, and then here we're at negative 3. We say, is positive 3 in seen? Yes, it is. So we'd update that with a positive 3. But in here is actually negative. So we can't just use in our maximizing function, because again, here would be negative and wouldn't be correct. We also need to check with the negative of it, because in any case, if it's negative, when we take the negative of it, it becomes positive. If it's already positive, this is covered. And obviously, it's never going to give the incorrect answer because we're only looking at positive values and we're maximizing it. So now we've updated our answer. We can't forget to put the numbers that we've seen in our set of seen numbers. So we just add it to the set, add into the set, and now we have our answer. And again, if we didn't get any correct answer, this answer is still going to be negative infinity, so we have to make sure we return -1 if that's the case. So we can return the answer if the answer is greater than negative infinity. Otherwise, we can return -1. And that's the syntax for this in Python. Basically just saying, if this is true, you do this. Otherwise, this. And, yeah, again, if you use zero or something here, you could just replace this with greater than 0, or if answer doesn't equal 0, anything like that. It doesn't matter. Let's submit it, make sure it works. Beautiful. Absolutely immaculate. Now, hopefully you can solve this problem on your own, and if you can't, do it again, I guess. Good luck, matey.